Welcome to another episode of Studysmart. In today's video, we have another sample problem to tackle on set, which reads as a man sells two types of engineering products A and B. 425 customers like product A, while 375 likes product B. If the man has a total of 500 customers, such that 80 customers who like product A also likes product B. So you should find how many customers like product A and B. And question 2 says we should look for, assuming that after an interval of time due to increase in selling price of each product, the number of customers who like product B reduces by 12%, and those who like product A reduces to 8%. So how many customers like neither, given the 255 customers like both? So we are going to start by analyzing the problem. So let's start from here. So let's analyze the problem. Solution. So we are given two products. So we are given two products. So given two products A and B. So these are two products we were given. So initially, from our previous videos, I gave a guidelines on solving sets regarding to Venn diagram. So since we were not asked on a specific method to use, we are still going to go with the Venn diagram to make it more easier for you. So the first one, I said, after looking at such problems, we are going to draw a Venn diagram using all the informations in manageable bits. So if you can see from the questions, they said a man sells two types of engineering products A and B, which means that this is a two-set problem. We'll have the first set problem, we'll have this first set to be A and the second set to be B. Alright, so we are going to analyze this problem by drawing the Venn diagram using the information given in manageable bits. So this is the Venn diagram of this problem. Then we have the first set, which is first engineering product A, and then we have the second engineering product, which is B. Alright, so we've gotten the first law, which gives us a hint of how to draw the Venn diagram using all the information in manageable bits. Then I told you again that after drawing the Venn diagram with all information in manageable bits, you are going to enter all the information in the set of the Venn diagram, including the universal set. So now from the question says that a man sells two types of engineering products A and B. So now 425 customers like product A. So 425 customers like product A. So 425, we are going to drop 425 here. 425 which likes product A, and then while 375 like product B. So this is product B. 375 like product B. So this is product 375 like product B. Alright, so if the man has a total of 500 customers, which means that the universal set is 500. Alright, so the universal set, the total number of customers is 500, which is the universal set. So this is 500. Alright, so we are going to look for, and let's proceed with the question. If the man has a total of 500 students, such that 80 customers who like product A also likes product B. So now the first question is, say we should find how many customers like product A and B. That is the number of customers that like both product A and product B. That's the intersection of A and B. So we don't know it. Let's just give this X, which is the intersection of A and B, which is this point. So we'll call here X. the number of customers that likes product A, the number of customers that like product A, that is the number of customers that like product A only, will be now equal to the number of customers that like product A minus the intersection of both, which is 425 minus x. 425 minus x. So I'm going to represent this thing here, 425 minus x. So this is 425 minus x, and then the number of customers that like product B only. So the number of customers that likes product B only will be equal to 375 minus x. So this is 375 minus x. So I'm going to represent that here. This is 375 minus x. So we've ended up in representing all the informations. We've ended up in entering all the informations of the sets in the Venn diagram, and as well as the universal set. Alright. So from there, we're going to solve the first question. We say we should find the number. Find the number of customers that like both product A and B. The number of customers that like both product A and B. That's the intersection of A and B, which is x, right? Which I told you from our initial class. One of the rules there, after you've represented all the informations by drawing the Venn diagram and then entering all the informations in the set, you are going to form an equation using the data you've entered in the Venn diagram. So these are the data we've entered in the Venn diagram. So we are going to form an equation with them. So if you check very well here, from the question, it was not stated that any certain number does not like neither product A or B. So there's nothing outside this set. So it's just like this, looking at the question. So forming an equation with the data we've entered in the Venn diagram, we are going to have 425, which is 425 minus x plus x, then plus 375 minus x, then we equate it to the universal set. So if you check very well from this place, we'll have minus x and we'll have plus x, which can go. So we'll have 425 plus 375 minus x equal to 500. Alright, equal to 500. So 425 plus 375 is going to give us 800. It's going to give us 800 minus x equal to 500. Equal to 500. So if I move 800 across the equal to sign, it's going to change its sign to a minus because it is having a plus here. So I'm going to have minus x to be equal to 500 minus 800. So this will give me minus x equal to minus 300. Minus 300. So this is a minus and this is a minus. If I divide both sides by minus 1, because this is carrying a coefficient of 1 here. So if I divide both sides by minus 1, I'm going to have, where this x, this minus will cancel out this. And I'm going to have x to be equal to 300, which is the answer for A. So we can conclude this by saying that the number of customers that like products A and B, which is the intersection of A and B, is equal to 300 customers. So that's the answer for question 1. That's question I. So we're going to move over to answering question II. So in answering question II, which is question II reads, it says we should assume that after an interval of time, due to increase in selling price of each product, which means for A and B products, after an interval of time due to increase in selling price of these products, the number of customers who liked product B reduces by 12%, and those who like product A reduces by 8%. And they're asking how many customers like neither, given the 255 customers like both. All right, 255 customers like both. So if you check well from question II, you'll notice that there are some percentages on it. The number of customers who like product B reduces by a certain percent, which is this 12%, and then the number of customers who like product A reduces also by a certain percent, which is 8. So before we proceed with that, we are going to firstly look for the percentage of the number of persons that finally, after they've reduced by 12%, the remaining number of persons that liked product B and the remaining number of customers that like product A as well. So we are going to start with dealing with product A. We're going to start with dealing with product A. So for product A, let's start for product A. So the number of we are going to look for product A. We'll firstly find the percent of the number of customers that liked product. The number of customers that liked product A was actually reduced by 8%, which means that the 8% of the number of customers that like product A should now be equal to 8 over 100, because percentage represents 100, times the number of customers that liked product A. Right, so this is the number of customers that like product A, 425. So the remaining number of customers that like this product A after it was reduced by 8% will now be equal to 8% of the number of customers that like product A initially. Alright, so the number of customers that like product A initially was 425, which is 425. So 8% of this 425 is going to give us 34. Alright, 34. So this means that the remaining number of persons after being reduced by 8% that like product A will now be equal to the number of the number of customers that liked product A initially minus the number of customers that liked product A after being reduced by 8%. So this will be 425, which was the number of customers that initially liked product A, then minus 34, which is now the number of customers that liked product A after being reduced by 8%. So this will finally give us 391. 425 was reduced by 8% of the customers that liked product A. It was remaining only 391 customers that liked product A. Alright, so we are going to do same thing for product B. This is for product B. So for product B, we are told that for product B, customers who liked product B reduced by 12%, which means that from initially the number of customers that liked this product B is 375. So the customers that like product B, which is 375, was reduced by 12%. Alright, was reduced by 12%, So it will be the 12%. If we run a calculation on this, we are going to have the number of customers that like product B will be number of customers that like product B will be 45 after they've been reduced by 12%. Now let's get the total number of customers remaining. So we are going to do same thing, 375 minus 45 to get the actual number of customers remaining after it has been reduced by 12%. So this will be 375 minus 45. So this will give me equal to, it's going to give me 330, which means that 330 customers liked product B after it has been reduced by 12% customers. Alright, so now the question went further to, alright, so assuming that after an interval of time due to increase in selling price of each product, the number of customers who like product B reduces by 12%, and those who like product A reduces by 8%, which we've looked for, which is this. And now they ask us to find how many customers like neither. Given it. How many customers like neither both? Alright, so what we are going to do firstly is we are going to denote the number of customers that like neither of the product. We've already used X in our initial representation. We've already used X here. So let's try using Y in another case now. So we can put down a statement to further explain it by saying that let Y represent number of customers that like neither of the product. And now to find the number of customers that like neither of these products, we are going to use this formula. The number of A union B, which is the universal set, minus Y, which we've represented as the number of customers that like neither of this product, will be equal to the number of customers that like product A plus the number of customers that like product. Then the number of customers that like product A and number of customers that like product B should be this and this we've gotten after they've been reduced by several percent. Alright, so this is 500 from our Venn diagram. We have our universal set here to be 500. This is 500. So the number of A union B is 500 minus Y should be equal to, now the number of customers that like product A, which is 391. So this will be 391 plus the number of customers that like product B, which is 330. This will be 330, then minus the number of A intersection B. So now from the question, don't forget we were given A intersection B from the question. Now let's go back to the question. They said how many customers like neither, given the 255 customers like both, which means that in this case we can say that we can write further at this point that since since n number of A intersection B is equal to 250. So this is 255 here. So this is what we have. So we are going to have 500 minus y to be equal to, so 391. So it's 391 plus 330 is going to give us 721, then minus 255. So 500 minus y will be equal to 721 minus 255. It is going to give us 466. So this will be minus y equal to, I will move over 500 across the equal to sign to have 466 minus 500. So this is going to give me minus y to be equal to 466 minus 500 is going to give me minus 34. So this is minus 34. All right. So if I divide both sides by minus 1, because the coefficient of y here is 1, I can cancel out these minus signs here. So I'm going to have y to be equal to 34. So we can conclude this by saying that therefore the number of customers that liked neither of these products is 34. So which is going to give us 34 as our final answer. Just like I told you from the last rule I gave you initially, I've given you several rules, and the last one I gave was after you form an equation using the data you've entered in the Venn diagram. So now, to ensure that this data you've entered in the Venn diagrams are equal, you are going to substitute the values you've gotten to the equation you generated. Unlike this point, we generated an equation here and we equated this thing to be equal to, we found y to be equal to 34. So if I should substitute the value of y to this generated equation here, the left hand side should be able to give me the right hand side. Alright, unlike these two, unlike the initial problem we solved earlier, we generated an equation with this Venn diagram to be this. This means that if I substitute the value of x to this point, then when I see x there, I should be able to get the universal set. Alright, so here comes to the end of. Subscribe, share to your friends, and then share your thought at the comment section. Don't forget to subscribe for more videos.